Okay, this one's section 15.3, number 1. And now we're doing two-dimensional integrals in order to find center of mass. And the reason why is that the density is two-dimensional. You might look at this and go, hey, this is just a rectangular plate. Can't I express its center mass in terms of a single variable? And the answer to that is yes, as long as the density was only a function of that one variable. But because the density is two-dimensional, there's no way to just take strips of it horizontally or vertically and think that you can locate the center of mass. So instead, we use roughly the same formulas. We're going to need to first integrate to find the mass, and to do that, we're just going to take the double integral of the density itself. So we want to integrate from 0 to 1 in the x, from 0 to 1 in the y, and then we want to integrate xy dy dx. And this will give me the mass of the shape. And what does this turn out to be? Well, it's pretty straightforward. Integrating, well, we're not really answering the whole thing. We're just going to do the inner integral first. So we're going to integrate from 0 to 1 of xy dy. So that's going to be xy squared all over 2 between 0 and 1. And substituting in for y, this will be 1/2 x. And then that becomes the integrand for the outer integral. So we're integrating now between 0 and 1 of 1/2 x dx. And of course that is x squared over 4 between 0 and 1, or 1/4. So 1/4 turns out to be the mass of this rectangle with this density. Okay, now we need the two moments, and so we need the moment in the y direction. Keep in mind that the moment in the y direction and the moment in the x direction are the moments about the y-axis, which means we're now going to integrate with an extra x. So it's the same integral, 0 to 1, 0 to 1. It's just instead of just xy, when we're integrating with respect to the y-axis, we add an extra x. So this is going to be x squared y dy dx. And just to save time, I've already worked out this guy. The my turned out to be equal to 1/6. And then the mx is going to be, everything else is the same. It'll go from 0 to 1, 0 to 1. But now, because we're integrating with respect to the x-axis, there'll be an extra y to compensate for where the mass is. So this will be y times the density, or xy squared. And this will be dy dx. As you might expect, because we're doing the double integral and the functions are pretty much the same with the same limits, this also turns out to be 1/6. And now we're ready to actually calculate our center of mass. So the x center of mass is going to be equal to my over m, and that's going to be 1/6 over 1/4, and that's 2/3. And y will be the same because it's the same ratio. It's just will be calculated from mx over m, and that's still 1/6 over 1/4, and that's equal to 2/3. So this shape, which is basically a rectangle, it just has this strange variable density which increases as we move across and up, and that means 2/3 will be the center of mass.